So I would like to ask from David Kennedy from Grosjean, who is also the coordinator of full 5G project, to moderate this session. So David, the floor is yours.
Thank you, Herlius. Our first speaker is the 5G Victory project, and I believe Jesus is already online and waiting.
So my name is Jesus Gutierrez. I'm the 5G Victory coordinator. I first want to thank Harry Laus for the opportunity of presenting here. Of course, we have many more things to say in 5G Victory, but I should try to somehow tailor the presentation and to these 10 minutes that I have available. So as you know, 5G Victory is an ICT 19 project. So the key 5G Victory objectives are to design and prototype an open 5G infrastructure capable of instantiating and co-hosting various vertical sectors. So the idea is that we take ICT 17 platforms as a reference with the experimentation facility and the experimentation blueprint they have in order to bring them or to extend them towards different sites, which are mainly operational environments, namely railway stations, factories, and so on. So we are covering 4 different vertical sectors like the media, entertainment, energy, transportation, and smart factories or factories of the future. So the idea is to integrate all these services brought by these vertical industries into operational environments, and then make the demonstrations related to that, and then showcase the different services, accounting for the network level KPIs that stem from the work done previously in the ICT 17 platforms and also in the 5G UK, and as well the vertical related KPIs stemming from the different vertical sectors. The idea is to propose and transform the current closed and purposely developed and dedicated infrastructures and into an open infrastructure that can be shared across the different sites that belong to each of the facilities, and as well across the different facilities that belong, in this case, to 5G Victory. The idea is to share and expose the resources in the shape of virtual network functions or physical network functions that can be included in different distributed repositories and can be accessed by the different facilities. So we have here on the right hand side the functional architecture of the 5G Victory project, where we see 4 different main blocks at the bottom of the figure, each of them indicating the 3 ICT 17 platforms, for example, 5G Genesis, 5G Eve, and 5G Vini, and then as well the 5G UK testbed. The idea of what we propose is to have a lean multi-site orchestration layer that goes or spans across them in order to facilitate the inter-facility use cases, inter-facility vertical services, and of course, the development of the related applications and related functions that also provide the accessibility to the different facilities. Regarding the use cases, we have, as we said, 4 facilities, 5G UK with different extensions, 5 Genesis with also some extensions supporting different use cases, 5G Eve and 5G Vini. The use cases are enhanced mobile broadband under high-speed mobility, which involves a vertical sector transportation, in this case railways. We have the digital mobility, which involves a cross-vertical interaction between the transportation and the media. Critical services for railways, which involves the vertical railway. Smart energy metering, which will run in the 5G Vini platform and involves a cross-vertical energy and rail. Digitization of power plants, as well in the 5G Vini platform involving the smart factory. And the CDN services in dense, static, and mobile environments involving a cross-vertical media and transport. We have chosen the green ones, I have chosen the green ones to show here. And also I have to say that it is not only a cross-vertical transportation and media, for example, use cases, but also are use cases that will happen in different facilities. So you can pick up the services and you can push the services from one facility to the other in order to run the service or to run the use case in another facility. Going into more details and concretely, I will focus in the 5 Genesis Berlin platform that Harry Laus mentioned before. So in the 5 Genesis Berlin platform, we have 2 different sites or 2 main sites. One being the Fraunhofer Focus site, which contains, it is the core site of the Berlin platform. It contains the Open 5G core, a software-based core that runs there, apart from 5G equipment that it's already been installed, has been installed recently in September 2020 at the rooftop of Fraunhofer Focus, and will be also installed in another parts of the site. We have as well the Humboldt University as another main site, and these 2 sites are interconnected in order to showcase and have the main use case of the Berlin platform, which is a Festival of Lights that Harry Laus mentioned before. So the idea in this case is to extend the Fraunhofer Focus site towards different sites in 5G Victory. So we forget about the Humboldt University. This will be done in the framework of 5 Genesis. And we are focusing here on one main site, which is the Berlin Central Station. So in this Berlin Central Station, the goal is to run 3 use cases that will also be running in another facilities, and I will mention afterwards this thing. What happens in the Berlin Central Station? One of the use cases, for example, is involves mission critical communications. And as we see, the Berlin Central Station is a safety relevant environment, which means that some of the signals that are already sent from the operations center in Berlin Central Station to the rolling stock may not be interfered. And so we need an additional site for testing some of the functionalities related to this mission critical use case. I will explain about this later, but I just wanted to show that there is an additional site called the Annaberg-Buchholz test field, which is a site owned by Deutsche Bahn, wherever they make tests, and you can have an ICE train running on a proprietary infrastructure, and you can do all these kind of things. We are talking about waypoint signaling, we are talking about interlocking, and so on. Additionally, given that Berlin Central Station is a key, one of the biggest stations in Europe, we have 2 additional sites for running the use cases if needed, which are Berlin-Jungfernheide and as well Betriebsbahnhof Rummelsburg. So the idea is to also have some contingency plan in order to run some use cases in case, for example, COVID-19 or any other event colliding in Berlin Central Station could impair the showcasing of the 5G Victory use cases. Then if we go into a bit more detail, what are use cases components? So we are focusing on 3 use cases: digital mobility, which runs in Bristol and in Berlin; rail critical services that runs only in Berlin; and use case 3, CDN services that run in the 5G Vini facility and as well in the 5 Genesis facility. What do we need here? So for example, in the Berlin platform, we need, for example, compute and storage resources, which will involve the 5G core network. Here we have the open 5G core network from Fraunhofer Focus, which is being extended to support multi-RAN 5G environments, and as well to support PCF and NEF for accommodating application functions, and as well to support 3GPP and non-3GPP technology interaction. We have as well 5G equipment in the RAN, of course, here highlighted in black, and as well 60 gigahertz millimeter wave with beam steering capabilities in order to provide connectivity to the train on the move. We have also here the color code. We have also some equipment related to the mission critical services use case in red, and as well to the CDN use case in green. You have here a list of the different equipment included in the office or in the H remote let's say site in Berlin Central Station, as well as in the wayside, onboard the trains, and as well in the platform user handset, 5G handsets.
Last minute now.
Briefly, with the use cases, digital mobility use case, we have a common framework for innovative mobility application. Wherever a user comes to the station and has a 3D capturing tool, whatever is able to capture the environment, and this front end, this application will provide this user for guidance within the station, and as well live recommendations for the next journey. As I said, for rail critical services, we have train control signaling, real-time high-definition CCTV, and mission-critical railway telephony, along with interlocking and wayside point machine signaling in the Berlin Central Station. And finally, we will have millimeter wave equipment steering the beam and providing high data rate connectivity to the train on the move for providing CDN services. And finally, the last slides is on the interfacility trial. So we have the 5G Victory operating system, which enables multi-domain and multi-age service delivery and orchestration, and offers key functionalities: end-to-end lifecycle management, service chaining, and multi-domain orchestration. And the difference to what has been already proposed in previous 5G projects are the mobility management capabilities and the profiling, plus the inter-domain orchestration with L3, level 3 connections. And this work stems from ICT 17 projects. So each of the platforms that we see here can be one of the ICT 17 on the 5G UK. And of course, it builds up on work done by 5G Picture and 5G UK Exchange.
Thank you very
and
much.
And this is, Jesus. Sorry for the rush.
Thank you, Jesus. No, very clear and quite exciting. Mind you, I'm a little bit worried what happens to the train once it's outside the station, but let's take that discussion offline.
Yeah, we will discuss offline. Thank you.
Okay. I'll move quickly on. Nobody posted any questions to you, so I'll move quickly on to the second speaker. If we can transfer the ball to Faouzi Bouali from the University of Surrey.
So, okay, thanks for inviting me to this workshop. My name is Faouzi Bouali. I'm leading the technical work on the transport vertical of 5G HART. And the name of my presentation for today is 5G for Advanced Automotive Use Cases, the 5G HART Perspective. So here's the outline I'm going to follow. I will briefly describe 5G HART. Then I will go through our list of use cases in transport, together with the associated trial facilities. And I will present a few highlights from our phase 1 results before concluding. 5G HART stands for 5G Health, Aquaculture and Transport Validation Trials. It is an ICT 19 project within or under the topic Advanced 5G Validation Trials across multiple vertical industries. It is a 3-year project that started the 1st of June 2019 and has been recently extended by 6 months due to COVID-19. We are basically targeting 3 verticals, transport, aquaculture, and healthcare. And as you can see here in this picture, so the cases we are considering in our 3 verticals involve a mixture of EMBB, URLC, and MMTC requirements across all verticals. Today, I'm going to focus on transport, the work I'm leading in 5G HART. Okay, briefly, if I go quickly through our list of use cases, okay, maybe to clarify our terminology, we use the name use case to designate a group of scenarios, and we have four groups of scenarios. The first one is platooning, where basically vehicles move like a chain with virtual strings between them. So this is expected to reduce the distance between vehicles, overall fuel consumption, and number of needed drivers. We've got 2 scenarios under this use case. The first one is high bandwidth in-vehicle situational awareness and see-through for platooning. And the second one is dynamic channel management for traffic progression. Both will be trialed on the 5 Genesis trial facility in Surrey. And here, the key requirements involve a mixture of EMBB and URLC. The second group of scenarios is autonomous assisted driving. So here the aim is to combine sensor data and communication capabilities to support advanced driving modes. We've got 3 scenarios under this one. First one is smart junctions and network assisted and cooperative collision avoidance. Second one is quality of service for advanced driving. And third one is human tachograph. So this is going to be tried on 5G TN in Oulu, Finland, 5 Groningen in the Netherlands, and 5 Genesis in Surrey, UK. And the key requirement is URLC. Third group of scenarios has only one, actually. It's a use case. It's support for remote driving. So here the idea is to remotely control a vehicle by either a human operator or cloud computing application. This comes with lots of benefits, including efficient road construction and potential control of multiple vehicles from a single operator. But more importantly, this can represent a cost-efficient and cost-feasible step towards purely automated driving. It's going to be tried on 5 Genesis, and it involves a mixture of EMBB and URLC requirements. And the last one, the last use case, we call it vehicle data services. So here the network collects actionable information from the vehicles and all road users to provide various services, including vehicle prognostics, over-the-air updates, smart traffic corridors, location-based advertising, end-to-end slicing, vehicle source HD mapping, and environmental services. It's going to be tried on 5 Genesis and 5 GTN in Finland. And the common feature here is the MMTC requirement, as we need the high density of nodes or devices. Okay, moving on to the trial facilities now, supporting these all these use cases. Our main one is the ICT 17 5 Genesis nodes located in Surrey in the UK. And we've got also 2 supporting national trial facilities, 5 GTN in Oulu, Finland, and 5 Groningen in the Netherlands. So the idea is to start with local tests and eventually evolve towards interconnected multi-site scenarios. Let me go through a few highlights from our phase 1 results. But before that, I need to clarify that for all our verticals, we are following a phased trial approach that comes in 3 phases. During the first phase, the idea or the aim is to explore various solutions, implement the most promising one, and conduct early trials. Second phase builds on top of the experience gained in the previous phase with potentially revised targets and scope. And the last phase moves to more advanced setups with interconnected multi-site scenarios. Right now we are in phase 2, but today I'm going to share some of our results from phase 1. So I selected one use case per trial facility for the sake of time. So starting with 5 Genesis. So the end-to-end slicing scenario is key to simultaneously support various applications running inside the same vehicle. For that, we are relying on the 5 Genesis trial facility presented earlier. So the experimenter's entry point to this trial facility could be the user-friendly portal or the open API for more advanced users. So we are sitting here as experimenter, but we are a sort of kind of special type of experimenter. For that, we are working closely with our 5 Genesis colleagues on low-level details to make the necessary arrangements to fit our needs and our use cases. The next steps is basically to finalize a work that we started, a work to develop a customized 5G instance with the required extra functionalities that are not supported by the basic 5 Genesis platform, namely URLC support and all the V2X advanced functionalities. Now, coming to some of the initial results. So I've got here some of the results for EMBB slicing from phase 1. So these were conducted in collaboration with 5 Genesis. So the setup here is basically a CPE used as UE, a customer premises equipment, and it's a non-standalone mode. So the CPE is connected to both 4G E node B and 5G G node B. So here I'm representing on the upper row the throughput results, on the downlink on the left, and on the uplink on the right, and on the lower row the round trip delay results. So we've got different here you have different statistics, basically the max, the mean, the first and third quartile, and the mean. But let's say the average value for the downlink throughput is around 500 megabits per second on the downlink. On the uplink, it's around 60 megabits per second, and the delay, the end-to-end delay or round-trip delay, is slightly above 10 milliseconds per second, which is way above the performance offered by 4G. Moving to the next trial facility, 5G TN. Here I selected the scenario T2S4, which is wearables-based human tachograph. So here the aim is to provide direct measurement and assessment of the driver's psychological status. So for that, we need to monitor the state of the driver and the potential risks from history data, for instance, sleep deprivation and high stress, for proactive measures to improve safety. So the setup is basically, the key element of the setup is a smartphone acting as a gateway device between the wearables and the network. And we've got the services running in the cloud. In phase one, we used a non-standalone, basically, mode, and we relied on Microsoft Azure for the cloud service. And on the UE side, we used different handsets with the gateway device for the fusion and the analysis functionalities. The next step for this one is first to relocate the data fusion of live and history data and the associated analysis to the edge. So these were running inside the smartphone in phase one, and now we are moving these to the edge. Second immediate task is to further optimize the 5G new radio uplink performance, as you will see in the next slide, still to be optimized. And last, to upgrade our setup with the extra functionalities from release 16, G-Node-B, for instance, standalone mode, and for multicast broadcast of warning, the EMBMS functionality, basically. Now, we use reference measurements for 4G LTE on the 2.6 gigahertz bandwidth in FDD mode with 10+5 megahertz bandwidth, and 5G new radio running on 3.5 gigahertz bandwidth in TDD mode with 60 megahertz bandwidth. And we've got different metrics that we managed, including throughput on both directions, end-to-end latency on both directions, and reliability. Here I'm representing some of our results for throughput. So on the top graph, you have the route. So basically, we performed the drive test, and we measured the throughput in each point of this route. So here in the bottom graph, we've got the result of the throughput on both the uplink and downlink, and for both technologies, LTE and 5G new radio. And as you can see, the performance of new radio, particularly on the downlink, is way better compared to LTE. Though the performance on the uplink is still to be optimized for new radio.
Okay, we're running out of time.
Last trial facility, 5 Groningen. So I selected the smart junctions scenario. So here basically we've got a setup that involves both 5G new radio and cellular V2X. And we, in phase one, we relied on an IP camera for the object detection functionality. Next step would be to connect an existing intersection controller by DINIC to the 5 Groningen network, configure the vehicle for priority requests over 5G, and add extra functionalities, including edge computing and slicing. Now, a snapshot of our results. So these were mostly 4G results that would serve as baseline for later 5G results. So here we have the distribution of end-to-end latency measured at the application layer. It's around like 25 milliseconds, with outliers reaching like 50 milliseconds, which is not enough for this scenario. Now, to conclude, in phase one, we explored various solutions and we designed the most promising ones. We've conducted different experiments using 4G and initial 5G setups. And for those who are interested, all this is documented in our public deliverable D4.2, which was delivered last May, end of May 2020. In phase two, we've been upgrading and optimizing our 5G setup. And the eventual aim in phase three is concurrent testing of different use cases, initially belonging to the same vertical, and eventually spanning different vertical industries. Thanks.
So we'll move straight on to the next presentation. Can we pass the ball to Andrea de Giglio, please, from 5G Solutions?
My name is Andrea Di Giglio. I'm from team, and you can see from this slide, I'm a coordinator of the 5G Solutions project. The project is a quite big project in line with the other one, more than 14 million euro budget, 26 partners, and we have experiment across all the Europe. In particular, we are basing our experiments on top of 5G Vini in Sweden, no, sorry, in Norway, in Spain, and in island facilities, and then we have in Italy our experiments based on 5G Eve platform. Ahead with the objective of the project, the main objectives are related to innovation. In particular, we are going to develop novel, realistic, and in particular business relevant use cases. Then some demonstration requires new technical innovations that in particular how to match the verticals needs with the 5G connectivity that the ICT17 can offer. Then, of course, the use cases should be, we should envisage that the use case will be viable in terms of business. So, okay, something nice, but of course, we need that this is affordable in terms of money. The last is that our project is not an island standalone, but we should disseminate our results both to peer experts, so for instance in the standardization bodies and or in conference, and to the common European citizens. I already said we are the main living labs, but I go to the details that saying that we are the main partners that are in Norway, in particular for the smart ports and smart city. We are going to Ireland, a lot of island partners going to Glambia, Orbis, and the help of Iris, that is a Spain partner but helps facilities there, then in Belgium and in Greece and in Italy. We are going to do the commitment of the project is really impressive in my opinion, because we are going to present 20 case studies belonging to 4 main living labs, also one living lab that is a multi-living labs that has the ambition to demonstrate that multiple use cases can run together on the same platform. The living labs are the factory of the future. So all the related to industry 4.0, then the smart energy in terms both of the charging of electric vehicle and to avoiding some peaks, some problems that we have in the common energy delivery both for houses then for factories. Then some interesting use cases for the smart cities, smart ports and media entertainment. As I said before, we are trying to understand and satisfying an impressive number, 140 specific KPIs that are more comprehensive of a technical validation, so understands if the performance is adequate to perform these use cases, and business validation, so in terms of affordable. But it's not going to the figures, going to the light blue box. We have the ambition to have the impact on the European citizen by reduce the pollutions, by have a wide approach to smart city, reducing on capex and opex in energy consumption, improve the safety and reducing crime, and improve the productivity of our industry. In terms of living lab, each of living lab have a particular KPI that we are going to respect. In particular, the challenge of a factory of the future is the data rate and the very short latency in order to, for instance, to understand the quality of products. We have a Procter & Gamble soap production that we needed to have a check for each product that exits from the production chain if is compliance with the standard. In particular, for the smart energy, we have the latency and the reliabilities should be very high. For the smart port is the data rate that, and smart city is the data rate and the number of connecting devices. For the media and entertainment, in particular gaming and video distributing, the data rate and the short latency is very important. This table just to demonstrate that the 5G is a real necessity and is not something that has ICT 19 project we try the way to use in the best way. Going ahead with the benefit of 5G, what we did since now and what we have to do. What we did since now, we are going to complete the cycle 1. Unfortunately, we are not in line what happened in the standards and of course with happening in ICT 17 projects. This is due of course to the problems introduced to the COVID-19 outbreak and the problems that to reach the facilities. So we have the chain that going to the success, in my opinion, that is to understand which are the requirement and specification, understand the KPIs. Then we set up the living lab and began the test. Then we have the first feedback and going ahead to redefine the requirements. In terms of what we do, we are ready for the third part for at least all the use cases, because we set up and apart and very interesting startup from Greece give the software in order to acquire data both from our 5G solutions platform and platforms of the connectivity that is provided by 5G, 5G Vini, and going to show which are the most critical parameters, which are the real performance end-to-end, and to check if the KPIs are satisfied. This is our most complete. The second is that we are going to set up our experiments. In particular, we have a first experiment in Live Lab 1 for the factory of the future, the one that I said before about the production of alimentary high-quality products from Glanbia and check for quality. And then we are going to finish some other case study in Smart City.
Last minute.
Yeah, I'm going to finish saying that we are going to begin our interaction that as potential feedback improvements apply to all the solution components in order to have a satisfying series going back to redefine some requirements in order to have the most challenging solutions from the 5G deployment provided by ECT 17 project. That's all.
Thank you very much, Andrea, and thank you for the effort to stay on time. So we'll move quickly on to the next presentation. Can we pass the ball, please, to Jussi Hapola to present 5G drones?
So, 5G drones. So, as the name says, we are all about drones. So, all of our use cases are drone related, and as you can see from here, we are 20 partners around Europe with expertise on telco vendors, telco operators, also UAV operators, UAV vendors, UTM operators, etc., and also research institutions. So in this project, we have actually all in all 12 different use case scenarios that we are investigating. So they're roughly categorized in 4 different use cases. So first being the UAV traffic management, also known as UTM, which is an essential feature in all drone-related operations. So it has 3 scenarios covering the command and control application, 3D mapping to support visualization and analysis software for UTM, and UAV logistics. So the second use case relates to public safety, and in there are 3 scenarios: monitoring a wildfire, disaster recovery, and police counter UAS operations. So use case 3 is focusing on situation awareness, and the scenario 1, which is infrastructure inspection, has actually 3 different sub-scenarios. And scenario 2 is UAV-based data collection, and scenario 3 is focusing on location in non-GPS or non-basic positioning system-based environments. Lastly, the 4th use case is connectivity during crowded events. And in the project, we have 4 different sites. So we have the 5G Eve at Sofia Antipolis and 5 Genesis at Athens, representing our ICT 17 facilities. In addition to that, we have 2 other sites, which is the Oulu 5G TS test network and the Aalto X network in Helsinki area. So as we said, there are 12 use case scenarios all in all. We have distributed them into different locations. This is also partially because of the various facilities have various physical areas that they are allowed to cover, and this kind of dictates what use case scenarios, especially when we are regarding drones that are fly and operate over significant areas, where they can be supported. So far, so we have on the left-hand side, we have the high-level architecture. So the project will build on top of the different facilities. So there is the trial controller and the use space to consider as well. So one of the main aspects from UAV and UTM point of view is to develop the use space adapter, which is essentially an interface to use space, and the use space is largely basically based on the CESAR joint undertaking efforts to cover unmanned space. It also uses learnings from Gulf of Finland use space project of which we have partners in. So the actual trial controller is the main endeavor as a common part of the project, and it covers a web portal for experimenters, then the actual trial execution engine, and also then there is the abstraction layer to interface with the facilities. So the experimenter will access the web portal. So there are in fact two different web portals. So the first one taking care of that the trial that an experimenter desires is feasible in the first place from the use case point of view, from the area of operations point of view, etc. Whereas the web portal 2 then focuses on the capabilities of the particular facility covering that area. And without going into further details, I'll start telling that we did manage to conduct and are in the process of conducting various feasibility tests. So even due to the COVID situation, we have managed to conduct feasibility tests, which are kind of precursor to pre-trials and trials. So feasibility tests on the 5G TN and the Alto X network platforms. And 5 days from now, there will be feasibility tests on the 5Genesis Athens platform. The 5Genesis Athens platform has also conducted emulation tests previously in May. And okay, to briefly cap, the feasibility tests purpose was to see how the components between the UAV operators, the 5G facilities, and etc. can start taking place, to learn which things work, which need improvement, what are the key pitfalls in actual execution of trials, etc., etc. So this picture here is the use case that basically we had in Oulu, covering command and control and 5G quality of service. So as you can see, the drone operator is actually in Estonia, Tallinn. Basically, all of the drone operators' software were in the University of Oulu edge server. And then, of course, on site there was the safety pilot. But as you can see, the main purpose of the safety pilot is just to hold the control, emergency control functions of the drone without actually touching the controls unless there is a situation. So the actual operations were conducted so from Estonia. We used 5G connectivity in non-standalone to connect with the drone and to carry out the quality of service. So with regards to feasibility test, I want to draw the attention. So in the figure in here, you can see three different user equipment from the three different operators. So each of them were doing speed test measurements, and you can see that the results are quite far from homogeneous. This is not a single, well, okay, this is a single instantiation, but it represents about the average of what we got from each of the devices over multiple trials. So the main message in here is that there are issues with the equipment stability on the market. So you can see that the downlink range was somewhere from 270 megabits to 400 megabits per second, and the upload was somewhere from 37 megabits per second to 20 megabits per second. And that is actually a thing that I want to emphasize, the uplink. So this kind of represents the 5G downlink uplink ratio that is at least used in Finland for the commercial operators. And this is a difficult feat for drone operations. So especially considering drones that have multiple different sensors and which require high bandwidth, for example, LiDAR and 3D mapping. This uplink ratio is, or uplink capacity is not really sufficient for operations. So there's quite a lot of thinking, basically, what can be done to convince and enable in the future actual 5G operators to push up that uplink capacity on demand. Also, okay, there are many issues with maturity, homogeneity, and tractability of each of the devices and components in the network. But that's it from my part. So thank you for attention, and all of the documentation can be found from our deliverables.
Very good. Thank you very much, Jussi. I think we're covering a lot of the aspects. We've covered trains, cars, planes. We're getting really into a lot of the vertical experimentation areas. We'll move quickly on. Next project is 5G growth. And this is presented by Carlos from the University Carlos de Madrid.
So thanks a lot for the invitation to be here to present 5 growth. So 5 growth stands for 5G-enabled growth in vertical industries. And in this presentation, I'm going to try to quickly provide an overview of the project, then just a couple of slides on the architecture, and then try to provide a glimpse also on the vertical pilot use cases, which I guess is the most interesting part for the audience. So very briefly, 5 growth is about validating 5G by performing field trials in 4 vertical sites, representing 3 kind of vertical industries: Industry 4.0, energy, and transportation. It's a project that leverages on results from past phase 2 projects, mainly 5G transformer, and that is applying and enhancing the ICT end-to-end platforms, ICT 17 end-to-end platforms provided by 5G Vini and 5G. As I mentioned, there are 4 pilot sites across three vertical industries. Well, it's 4, but one of them is Industry 4.0 in 2 sites. And we have 90 different use cases that we will perform in these vertical sites. The consortium is formed by 21 partners, but I will not go into those details. The vertical pilots or the vertical sites are located in Spain, and Phytonic site, in Portugal, in Aveiro, 2 different locations from the energy and from the transportation, and in Italy for the Comau factory. And well, in Spain, it's actually Phytonic and in Bouali in the Basque country. These pilots require the development, installation, validation, and testing of pre-commercial 5G radio transport and core technology, in addition to the connection and the mechanisms provided by the ICT 17 platforms. As I mentioned, the Industry 4.0 pilots are the one from Innovalia in the north of Spain, the one from Comau in Turin, and then the energy is EFASEC Energia, and the transportation also from EFASEC in Aveiro. Then we rely, as I mentioned, on ICT 17 projects, 5G and 5G Vini, which are key for us because they provide 3 different things. One is that we use ICT 17 platform for the first test and validation of our vertical pilots. And we already did a gap analysis trying to identify what we need to provide in addition to what ICT 17 already provide, which is quite a lot. That was performed at the beginning of the project. Then we started designing and implementing and deploying the missing components, missing functions required for the vertical trials to be deployed and validated, including the ICT 17 platform capabilities and what we need to develop in the vertical sites. And this requires the 5 growth platform itself, which provide additional innovations on top of what 5G, or what we can say call plain 5G, provides. And then we integrate with the vertical systems on the vertical pilots and with the ICT 17 platforms to provide this validation platform, validation tests that we aim at doing at 5 growth. Then very briefly about the 5 growth architecture. The 5 growth architecture, I will not go into the details, is composed of 3 main building blocks, which well, actually are more than 3, but these are the 3 main ones that we start from that are basically inherited from 5G Transformer project. A vertical slicer on the top, which is the entry point for the vertical to provide the requirements in terms of what they need, the services need to be provided by the platform, and is where we do the mapping between the vertical services and the network slices that are deployed in the network. Then we have below the service orchestrator, which is in charge of doing the orchestration of the multiple resources and services that we can encompass or we can put together to provide the vertical service. And this service orchestrator is on top of the resource layer, which is where we have the physical and virtual resources, the RAN and the core, and that provides a unified view to the orchestrator to manage the end-to-end services, end-to-end slices that we have. In addition to this, in order to do the new or some of the new innovations that we do in 5 Growth, we also added some new components, mainly related to enhanced monitoring for better SLA and closed loop service orchestration, and also an AI ML platform that is used by different mechanisms, different innovations that we have in the project. This is, I mean, just a very brief overview. You want details, you can go to the deliverables of the project. And you can also try and play with the first release of the software of the 5 Growth platform that we released in May 2020. You have there the links for the GitHub, and you can download the code and play with that. And of course, if you have any questions, you can get to us, and we will try to help you developing or deploying this to your site. Then regarding the vertical pilots or vertical use cases, we have these 4 pilots that are these 4 boxes there. And then each of the pilots have identified different use cases, all of them based on TRL 6.7. We have 2 for Innovalia Industry 4.0 pilot, 3 use cases for the Coma Industry 4.0, 2 for the transportation, and 2 for the energy. All these use cases are being developed in parallel at the same time. And before the actual development of the pilots or deployment that is taking, well, is started some months ago and is basically now on one of the most busiest periods in terms of putting effort into putting this into place. We did a mapping of the different technical KPIs and business KPIs, although in this presentation I only go through the technical KPIs for each of the 9 use cases you have there. Innovalia 1, Innovalia 2, and so forth, and so on and so forth. Trying to have a picture of what are the key KPIs for each of the use cases. And as you can see, basically, we cover pretty much the whole 5G spectrum from METC to eMBB and the URLLC as well. So we have all the different KPIs mapped there that we will have to validate to the actual pilots. And then just one example of the many or the 4 pilots that we have, and one of the use cases that is the Industry 4.0 pilot from Innovalia in Spain. So basically this pilot is about enabling a much more flexible approach for the calibration of measuring machines in a factory. So this is a procedure that is required where an expert metrologist has to go there to the factory and configure the machines to be able to measure the different pieces that are built. And this requires basically the person to go there, and we want to avoid this on the one hand. And then another thing that requires is a lot of data to be transmitted in real time from the machine to the computer that is taking care of the calibration of the machine. And typically that requires wire to be deployed, and this is basically expensive and limiting in terms of the mobility of the operator. So the first use case that we have in 5 Growth is basically to enable this to be done remotely through 5G connection. We want to support remote real-time operation via virtual joystick that is capable of controlling the machine to be configured, the measuring machine to be configured. That also requires video, real-time video in actually more than one camera or 360 video for the operator to remotely be able to see what he's doing. So basically we have eMBB here, and we have will see here. In this particular use case, the vertical is in Novalia in the north of Spain, the operator is Telefónica, the vendor is Ericsson, and then we have also Interdigital, Belkacem, and Jussi 3M involved in the development of this particular use case. Currently, we have already received a measure machine in Pythonic, and we are doing integration of connecting this machine via 5G. And once we have that ready, that should be in the next few days, we will start integrating into the FiGrowth platform and connecting with 5G and doing additional tests. This is what we have in the near future. And with that, I think I'm in the 9 minutes, so I don't want to spend more time. This is just as a summary. If you have any questions, I will be more than happy to address them.
Perfect timing, Carlos. Thank you very much. So we'll move on to the next presentation, which is the 5G Tours project. And there we have Bel Mouhouche from Samsung.
So this is a quick presentation for the 5G Tours project. Of course, we have only 10 minutes, so I'll try to go to the essential and describe quickly the project, and then go through all the verticals that we are addressing. So yeah, so some key facts quickly about the project. So the project name is 5G Tours, and it's a 3-year project from June 2019 to June 2022. The project coordinator is Ericsson Italy, and the deputy coordinator is Telecom Italia. Myself, I am the technical manager. I work for Samsung, and the deputy TM is University of Carlos III. And we have 3 innovation managers across the 3 nodes in Italy, and Rennes in France, and then Greece. So what's the vision of our project? So the project actually tries to enhance the user experience as a tourist, for example, visiting a city, making the experience better in terms of visiting museums and in terms of safety as well. So we have three axes. One axis is the touristic city, which is based in Teran. And in this, we try to improve the experience of the user when visiting the museum, providing him with the media to watch events that are taking place. And the other axis is the safe city in Rennes in France, in which we have use cases about the health use cases. So if something happens to a visitor or a tourist, we try to get the ambulance to him as quick as possible, and then monitor him while in the ambulance until he gets to the hospital. And the third axis is the mobility efficient city in Athens, in which we have 4 use cases related to smart parking, to quick navigation in the city, and then the safe and efficient airport. So this is the main vision of the project. Okay, so the goal of the project is to look at a set of requirements, and then you have a set of requirements as for individual use cases, and then we try to make sure that sometimes competing or conflicting use cases are managed and are supported together in a different verticals. So this is the overall the main goal of the project. So as I said, we have 3 beautiful cities, Turin, Rennes, and Athens, in which we implement our trials. And the 5G Tours approach is described here. So unlike some of the other projects, we are fully based on 5G Eve. So only one ICT 17 project. And on top of 5G Eve, we bring the innovations that come from 2 previous EU projects, 5G Monarch and 5G XCast, related to orchestration and broadcast technologies respectively, to which we add some innovations that are the product of the 5G Tours project. And all this will boil down into the architecture of 5G Tours that will enable us to support the 3 cities that I mentioned. And on top of the 5G even all these innovations, we have the verticals that are related to the media, the health, safety, and mobility solutions. And you know, all this architecture is built in order to make sure that the user experience across all these verticals is made better. Okay, so yeah, so this is the architecture. So as I said, it's based on 5G Eve. And then on top of it, we have the innovations related to enhanced MANO and elasticity, related to AI-based analytics, and related to a broadcast technology for release 15 and upgrade to release 16. And on top of this, we have a service layer that will translate the requirement and the needs of the tenants of the verticals into the platform 5G. And on top of the service layer, of course, we have the vertical tenants which use the network in order to provide the service related to the museums, related to the hospital, the ambulance, and so on. So this is the idea. Okay, so the consortium partners. So we have, you can see here all the partners. We have 28 partners, and I won't go into the details here. But if you look at the three sites, you see how we address the each site. So for each site, we have mobile operators, and then we have network infrastructure manufacturers, and we have vendors and chipset providers across all the sites, as I said. And then we have vertical customers. So for example, we have the hospital of Rennes, we have the airport of Athens, and then we have the museums in Turin. And then we have the vertical solution providers. So these are people that implement the vertical solutions, like LiveView, Wings, and in addition to that, we need to implement new technologies. So we have technology and innovation innovators and analysts. So some people do the innovations like UC3M, and then some people do the analysis like Real Wireless, and some people do the as Real Wireless as well. They do the economic analysis as well. Yeah. So what are the use cases or the verticals that we address here? So in Turin, I will go quickly. Unfortunately, we have 13 use cases, so we don't have time to go into the details. But I will give you just an idea about this. So in Turin, we have 5 use cases related to augmented tourist experience. So we improve the visitor of the museum experience. We have also telepresence, in which we have a remote museum visit. This is very good in terms of meeting the needs of people, especially in COVID-19, to enable people to visit telepresence and visit remotely the museums. We have a robot-assisted museum guide. We have a video distribution that uses broadcast for large-scale media distribution. And then we have distributed video production, in which we have a very, very interesting use case, in which we have an orchestra, distributed orchestra, playing the music together and making sure that the delay is low, so that the perception of the ear of the music is still like if everyone is in the same place. In Rennes, we have 4 use cases centered around the safety. So we have the hospital, sorry. So we have the hospital of Rennes, in which we have remote health monitoring and emergency management. So if something happens to a tourist, we enable the connection quickly with the hospital. And then we have teleguidance for diagnostics and intervention support, in which we are saving, we are aiming to save life through improved assistance while the patient is going to the hospital in an ambulance. Then we have the wireless operating room, in which we have an operating room connected so that different people can access the operation and can help with the patient. And finally, we have the optimal ambulance routing that enables the ambulance to, quickly reach the hospital to treat the patient. And for Athens, we have the mobility efficient city. So we have smart parking, we have enhanced ground-based moving vehicles to help the with the airport logistics. We have the emergency airport evacuation in case of emergency, and then we have AR/VR education excursion, in which we provide AR/VR experience for educational reasons. Yeah. So this is an example of a touristic city, different verticals, different actors, different networks, and we have done this work for the all the 13 use cases. So if you are interested, you can go to the to our website 5gtours.eu, where you can see all the details. So the current status now, we have set the requirements and refined them. We have set the architecture. We are starting the implementation across the 3 nodes, and we are preparing some demonstrations for the midterm review. We have set up the evaluation methodology, and the innovations of the project and disseminations are also described in the deliverable, and we are disseminating the project and providing input about our progress. So if you want more details, yes, I'm just finishing. So if you want more details, you can go to 5gtours.eu, or you can go to our YouTube channel, where you can see all the videos related to our use cases. And you can follow us. Sorry, you can follow us on Twitter to get the updates of what we are doing in the different nodes. So thank you very much for your attention.
Thank you, Bill.
And thank you for the organization as well. So I forgot to say this at the beginning.
Very good. No, there is a good team behind this event in Democratius, and they've done a lot of work on organizing the agenda, getting all the speakers. So yes, credit to them. So I think we'll move quickly on to the next speaker from 5G Smart, and that is Leefke Grosjean from Ericsson.
So hello everyone, my name is Leefke Grosjean from Ericsson Research, and I'm the project coordinator of 5G Smart. And in this presentation, I will give you a short update on the latest status on the trials of the 5G Smart project. Let me start with providing you some brief insights into the project. We are an ICT-19 project with contributors from both the ICT domain, the OT domain, and academia. And to the right, you can see all the partners involved. We've started the project in June 2019, and the project ends in November 2021, so we're a bit more than halfway into the project. A quick look at the 5G Smart objectives is presented on this slide. On top, the industry field trials as one of our major objectives. Here we're aiming at demonstrating, evaluating, and validating 5G systems in industry field trials for smart manufacturing. Next objective is to identify viable business models for smart manufacturing. And in terms of concept work, we develop new 5G technology features and analyze and evaluate 5G radio deployment and network architecture options. Overall, the goal of the 5G Smart project is to show how 5G can boost smart manufacturing. Now, the project is divided into 6 work packages, and you can nicely see on this slide how 5G Smart spends its efforts over the entire path, going from the integration of 5G into the manufacturing ecosystem to actual trials and to optimizing 5G for smart manufacturing. The focus in this talk is on the trials, which are here in the core part of the project. So let's have a closer look at these. Here's an overview of the 5G Smart trial sites. 5G Smart has 3 trial sites at different places in Europe. To the left, the Ericsson Smart Factory in Kista in Sweden. The view we can see is right before the entrance to the factory. At the Ericsson trial site, we have a test area of approximately 50 square meters close to the production line. The network we've deployed here is a 5G non-standalone network, an isolated non-public network operating on NR high band at 28 gigahertz and with an LTE anchor in mid-band at 1.8 gigahertz. Over to the next trial site, the shop floor of the Fraunhofer IPC in Aachen, Germany. Here, 5G Smart is operating in a 2,600 square meter large indoor deployment covering the shop floor, as well as an outdoor area, and all of this in close connection with the Industry Campus Europe. At this trial site, we have deployed a 5G non-standalone network, again as an isolated non-public network, so no mobile operators involved. A transition to standalone 5G is planned for 2021. In terms of spectrum, we are making use of the German industry spectrum at 3.7, 3.8 gigahertz with an LTE midband anchor at 2.3 gigahertz. Our last trial site is a bit different from the other two. It is a Bosch semiconductor factory in Reutling, Germany. This is a 24/7 operating factory producing semiconductors for airbags, phones, etc. So this is not the testing area, but a production area. We've equipped one of Bosch's 8,000 square meter large factory floor with a 5G standalone deployment. So as opposed to the other trial sites, this site we will have standalone deployment from the beginning. Again, we're making use of the German industry spectrum at 3.7, 3.8 gigahertz, and with the deployment here being standalone, no LTE anchor is needed. In terms of the trial site practicalities, this site is the most challenging as we should not interfere with the ongoing production and we need to adjust to all kinds of constraints that come with a real factory. In this case, for instance, the deployment has been made in a clean room area, so an area where the number of particles in the air is far less than a normal room. And that is why in the picture that we've seen here before, everyone is wearing overalls and gloves and all items and devices brought inside this clean room need to be cleaned from dust first. Okay, so this gives you an overview of the 5G deployments that we've made at the different trial sites up to this point. And let me now give you a bit more insights into the kind of use cases we're planning or have been starting to run at these sites. Let me again start with the Kista trial site. Here we're looking into 3 different use cases listed here to the left and partly illustrated to the right. The first use case is called 5G connected robots and remotely supported collaboration of connected robots. And this is the setup that we see here. 2 stationary robots and a mobile robot connected with 5G will work on solving a task collaboratively, while major functionalities needed to realize this task are moved to the edge cloud. The second use case looks into machine vision assisted real-time human-robot interaction over 5G. This basically means that we will mimic the situation where a technician is moving around on the factory floor interacting with a robot. And then we have the third use case that is about 5G aided visualization of the factory floor. And here we're looking into the situation where a factory owner or a technician is moving on the factory floor wearing AR glasses. And with the help of the AR glasses, information, for instance, on the health or the battery status of the robots can then be retrieved. Overall, the challenges explored at the smart factory in Kista is to allow a seamless operation of the robots while major control functionalities are moved to the edge cloud, including, for instance, motion planning, robot localization, etc. In terms of the latest status, as indicated before, the 5G deployment is finalized. We have collected all the requirements for the use case and we are now in an intense phase of the use case development. And we hopefully have a first demo ready towards the end of the year. Now we can move over to the second trial site, the Fraunhofer IPT shop floor in Aachen. Here we're looking into 2 use cases illustrated to the right and to the lower part here. The first one is 5G for wireless workpiece monitoring, and the process that we're monitoring is a cutting process, and we're making use of an acoustic emission sensor that transmits data wirelessly to a monitoring system, which based on the received spectrum can then detect tool wear or breakage or things like that in real time during the cutting process. The second use case involves the development of a multi-sensor platform. A multi-sensor platform is a device with a number of different sensors, such as gyroscope, temperature, whatever sensor could be needed for the particular shop floor. And this device can be configured to different use case scenarios and be adjusted to deliver process and condition data with different criticality and priority. And the challenge for both use cases is that the signal processing will be performed on an edge gateway or by cloud computing. In terms of latest status at the Aachen trial site, we have finalized the 5G deployment, use case requirements have been collected, and the development is ongoing. A first demo has already been shown, and we are therefore also going into the phase of evaluations and validations. Now over to the last trial site, the Bosch semiconductor factory. Here we're in the process of realizing 2 use cases. The first use case is on cloud-based mobile robotics. We're in the development of a mobile robot connected over 5G that will move on the factory floor. And here again, major control functionalities will be moved to the cloud. And in addition in addition to that, to this mobile robot that we are building from scratch, we will also have another robot or a number of other robots that we will have a common map and map sharing together that will walk around on the factory floor. The second use case is realized again at the semiconductor factory, and here we're investigating and validating the applicability of 5G for transporting critical machine-to-machine traffic of TSN and industrial LAN applications, and we look in particular into controller-to-controller applications. In terms of latest status, we finalized the 5G deployment, and the use case development is still ongoing, offsite still, but we're planning to move on-site next year and hoping that the situation around Corona will allow us to do so then. At the Bosch trial site, we have an extra activity that has very recently been concluded. 2 measurement campaigns have been conducted. The first one being a channel measurement campaign at 3.7 gigahertz and 26 gigahertz, conducted by the University of Lund, and this is to better understand the channel characteristics in this challenging environment. This factory floor has lots of machines installed, very narrow corridors, lots of reflective material, so it is not very much like, for instance, an office area. But we're still in the evaluation phase there. The second activity are on electromagnetic compatibility tests to understand the effect of 5G signaling on these very sensitive semiconductor and sensor production equipment. And the challenges we were facing here while conducting these tests were most of the practical side, so our measurement campaign had to be undertaken in the operational factory with all the strict requirements on safety, clean room adjustments, etc. And so on the latest status of these activities, you can see that all measurements have been concluded in September now, and we're in the evaluation phase.
Last minute.
That was all about the latest status on the trials in the 5G Smart project. In summary, all trials are now operational. The use case development is in an intense phase, and evaluation and validation will take place during 2021, with final results being ready in Q4 2021. That was all for me. Thank you for listening.
Thank you, Leefke. Very nicely on time as well. Much appreciated. Okay, we've had all of the technical projects. The next one, it seems to be me. Okay, I've decided to take a different approach with just presenting the full 5G. You've all had interaction with us as the support action. We've nagged you over various points to give us details and put the information of the community together. The set of projects we're dealing with has been a growing community. If you see the diagram on the screen, it actually represents the different phases of the 5G PPP. I don't know how we ended up with so many labeled as phase 3, but I can blame Didier for that if he's still online. But I'm still. Okay, good. We are actually here in this cycle. So I don't quite agree with Dan that we're at the beginning of the end. We have somewhere between a third and a quarter of the program left to go. We have a number of projects that will start early next year from the last round of calls. I think it's 41 and 53, and there's a lot of work still to be done. We're in an exciting phase which has already been represented by a lot of the presentations you've just heard, which is where the projects are building on each other and achieving interactions through close connections and close working connections. Actually, I have a little bit of news for you in that I heard this morning that here under the 53, ICT 53 projects, it looks like the Commission have managed to squeeze a little bit of budget to add one more project to that collection. So I'll confirm that later today, and we'll hopefully have yet another project joining us in this activity. As we talk about the interworking, one of the things the support action does is it looks after the collaboration agreement. Now, ICT 19 is fully started up. There was one little glitch, but it's been solved. ICT 20 were fully signed up in record time, and we're now working on getting the 42 and 53 projects signed up. I don't have 5G rail on this diagram yet. I believe actually this morning 5G routes sent me the final one, so they'll now go green and we'll have the rest on. The collaboration agreement is actually the critical infrastructure behind supporting the open interworking between projects. Under Article 41.4 of the collaboration agreement, we are all complementary projects, and we should have we are obliged by our grant agreements to have a collaboration agreement to allow us to work together closely. And it looks, from what I've just heard in the set of presentations, it's working well. Okay, what do we do together? Well, we do all sorts of things. You know, the steering board, the technology board. We have events. You're in one of them at the moment. Always go to the event page in the website if you want to see what's happening. We have work groups, and they produce quite substantial results, and people are listening. This is one of the things I do want to get across to you all. The results from the collaborative activities between the projects are making an impact. Just an example, that's the list of papers. You can see the CCAM paper went up only this week. The strategic deployment agenda for CAM also went up in the last period. So we've got new ones up quite frequently, and I know there's a few more there that will come out shortly. This is just a page you don't often see, and I'm sharing it with you to let you know where we are in the world. The website, just in the last period that we're reporting on, it's had quite a number of visitors, a lot of new visitors. The blue is the new ones and the green is the returning. So there's quite a lot of new people continually coming along to our web pages. Sometimes we seem to have a high bounce rate, but this actually includes going out to project pages and that which are linked from the website. So it's not as dramatic as it seems. Who's listening? Well, actually, the previous year we looked at this map and there was no one from Greenland, but now even Greenland is actually one of the IP addresses looking. The heavy use seems to come from America. There's a lot of inquiries or accesses from there. And as the colors get slightly darker, you can see the different degrees. But it is becoming a global phenomenon. There is a global audience for our 5G PPP activities. For curiosity, what are the top hits? Well, you can actually see the white papers page is one of the top. The phase 3 projects explanations also high up on the list, and the trials roadmap and so on. But if we actually then look in downloads, you can see architecture white paper, software white paper, roadmap version, whatever. People want and consume the output from the collaborative activities. So as a support action project supporting this, we're proud that you guys are working together and producing stuff, and we're very happy that we are making an impact and getting a lot of global attention with what we're doing. I think we should start campaigning on a Europe first headline. Okay, to finish up, I'm trying to recover time for you. I'll remind you about some of the events coming up. The Internet of Radio Light are having a workshop. Again, look at the events, find the information. We're planning an ICT 18 and 53. I'll have to discuss if the new ICT 53 project can also join that on the 6th of November. That'll go up in the next day or two if all is confirmed. And we hope to have similar sessions for the ICT 20 and ICT 42. The technical board session mentioned in December by Alex at the start of the day, he actually is organizing that. I don't know if we'll put that up as a public event or it'll be restricted. It depends on the level of technical discussion. If it's quite deep technical discussion involving project information, it will not be a public, it'll only be available to the organizations who are signed into the collaboration agreement. That's all I want to say about the full 5G project at this stage. Of course, you can always contact us through the website or whatever if you want to know any more about that.
With the question that has been set for 5G Victory, Jesus, as you have seen, I will be interested to know a little bit more about the millimeter wave Teran system they are put on the top of Train. I don't know if you can comment on this.
Okay, I will be fast and to the point. So in the framework of 5 Genesis, we have IHP, we have developed a solution that is, as Harry Laus mentioned, able to connect from the Humboldt University building remotely, a millimeter wave connection to a remote edge deployment in Berlin, right? So we have built that based on a proprietary solution, SDR platform plus CIVA front-end with 16 TX RX, let's say beamforming channels in a way. And but this is mainly tailored to static environments. Talking about mobile environments, like for example, in 5G Vini, Patras facility for 5G Victory, we are planning to provide connectivity to a train on the move. Thinking about that and regarding the form factor to be installed on top of the train, we are thinking probably about a commercial solution, either based on MikroTik technology or Intracom Telecom technology. Given that the one that is built for the purpose of 5G Genesis is a bit big and probably does not comply with the height that one has to, let's say, account for when installing something on top of the rooftop of the train. So that's why probably this MikroTik or Intracom solutions would be more suitable for this purpose. But we have to say that the one deployed in the 5G Genesis project is able to do point to multi-point connectivity as well as beam steering.
But the steering, it's a mechanical or it's an electronic steering?
No, it's electronic steering. So it's based on phase shifters. We have previous solutions with vector modulators, but this one is a bit more simplified with phase shifters.
Okay. And frequency range was here?
So we normally cover the 4 channels of 11AD, let's say. 2 gigahertz channels, able to cover the 4 channels. So we are able to basically cover the 4 of them, although we are not doing channel bonding, so we use them separately.
Thank you.
Thank you. All yours, Harilaos.
Okay, thank you very much.
Everyone, thank you for your attention for the session. Thank you to the speakers because they really gave us a lot of information in a short time. And I'm very happy it shows the heavy level of interaction between the ICT 17 and 19 projects. That is a wonderful achievement for this program. Thank you, Harlius, for organizing that session.